Today we are going to discuss about the continuity of a function.
Take a look at the functions and their graphs. Let's analyze the graphs. If we draw these graphs with a pencil, then we see that the first two graphs cannot be drawn without lifting the pencil. While the third graph can be drawn without lifting the pencil. It means that the first two functions are not continuous, while the third function is a continuous function. Mathematically, a function is continuous at x is equal to c if the function is defined at x is equal to c, and the value of the function at x is equal to c is equal to the limit of the function at x is equal to c. Now, let's interpret these graphs by determining the left and the right-hand limits of each function. Let's start with the first graph. It is clear that the value of the function is equal to 2 for all negative values of x. This implies that at all points near and to the left of 0, like minus 0.01, minus 0.001, minus 0.0001, and so on, the value of the function is 2. Thus we can say that the left-hand limit of f at 0 is 2. Similarly, at all points near and to the right of 0, like 0.01, 0.001, 0.0001, and so on, the value of the function is 3. Thus the right-hand limit of f at 0 is 3. The value of f at x is equal to 0 is 2. Observe that the left-hand and right-hand limits do not coincide. Also observe that the value of f at x is equal to 0 coincides with the left-hand limit. Therefore, the function is not continuous at x is equal to 0. Next, consider the graph of the second function. In this case, the left-hand limit and the right-hand limit of function f are both 2. However, the value of the function at x is equal to 0 is 1. Here also, the value of the function at x is equal to 0 is not equal to the left-hand limit and the right-hand limit. Hence this function is also not continuous at x is equal to 0. Now observe the third graph. In this graph, the left-hand limit, the right-hand limit, and the value of the function at x is equal to 0 are all equal to 1. Hence we can say that function f is a continuous function at the point 0. Let's phrase the definition of continuity. Suppose f is a real function on a subset of real numbers, and c is a point in the domain of f. Then f is continuous at c if the limit of f of x as x approaches c is equal to f of c. If f is not continuous at x is equal to c, then we say that f is discontinuous at c, and c is called a point of discontinuity of function f. Let's apply the definition of continuity to check the continuity of a function f given by f of x is equal to 3x plus 1 at x is equal to 1. It is clear that the value of the function is 4 when x is equal to 1. Next, we'll find the limit of the function as x approaches 1. This is given by limit of 3x plus 1 as x approaches 1. This is equal to 4. Thus, the limit of the function coincides with the value of the function. Hence, the function is continuous at 1. Let's now check the continuity of function f of x as shown at x is equal to 2. From the definition of the function, it is clear that the value of the function at x is equal to 2 is 6. Next, the limit of function f of x as x approaches 2 is equal to 7. Here, we see that the limit of the function and the value of the function at x is equal to 2 do not coincide. Hence, the function is not continuous at x is equal to 2. Let's now check the continuity of the function f of x. Let's now check the continuity of the function f of x is equal to sine x in the closed interval 0, pi. The graph of the function in the closed interval is shown. It is clear from the graph that the function is continuous at every point that lies between 0 and pi. However, if we say that function f of x is equal to sine x is continuous in the closed interval 0, pi, then we need to show that it is continuous at every point in that closed interval. So let's check the continuity of the function at its endpoints. The right-hand limit of f of x at x is equal to 0 is 0, which is the value of the function at 0. The left-hand limit of f of x at x is equal to pi is also 0, which is the value of the function at pi. Hence, the function is continuous at the endpoints. Here, we do not need to find the left-hand limit of the function at 0 and the right-hand limit of the function at pi. This is because the points left to 0 and right to pi do not lie in the given domain. Thus, mathematically, a real function f is said to be continuous if it is continuous at every point in the domain of f. Let's study the nature of the function. F of x is equal to 1 divided by x as x approaches to 0 from the right. That is, we intend to find the right-hand limit of the function